Okay, another typical problem in AP Calc and in this course is the revenue problem. So basically how a revenue problem works is that you run some company and somehow you get some data that if you increase the price or decrease the price by a certain amount, it's going to either increase your customers or decrease your customers. And you got to figure out how to maximize revenue based on this. So for example, a bus company carries about 15,000 riders per day for a fare of 80 cents. So this isn't super realistic because I don't know what it costs to ride a bus anymore, but it's sure not 80 cents. So that is what it is. Survey indicates that if the fare is increased by 5 cents, the number of riders will decrease by 1,000. So you lose a lot of riders every time you increase the price by 5 cents, and probably vice versa. If you decrease the price by 5 cents, then you're going to increase. So it's always this kind of assumption that however much it decreases by, if you do the opposite, it'll increase, or vice versa. So we want to find the ticket price that'll result in the greatest revenue. This is always a tricky one to set up, but how I always set up my variable is that I'm going to say the variable, I'm going to let x be the number of times we're actually going to increase the price by 5 cents, which is a little tricky, but because that's our unit is 5 cents, it just makes setting everything up easier. So I'm going to define the variable. Okay. What this means is now for every revenue problem, so what revenue is revenue is always your price times the number sold. So it's how much people are willing to pay times how much you can sell gives you how much total money you can make. So that's what revenue is all the money you come in. It's not profit, it's just revenue. So it's your income. So we need a formula now for the price and for the number sold. So our price is normally 80 cents, but we're going to increase it by 5 cents x times. That's what x is the number of times we're going to increase the price. The number we can sell is normally 15,000 at 80 cents, but that's going to go down by 1,000 every time you increase the price, which is we're going to increase the price x times. So again, this is what this x does for us, and it just makes a nice formula. So now we can go, okay, revenue equals, the price is 0.80 plus 0.05x. The number sold is 15,000 minus 1,000x. And we're going to graph this and find the vertex again. Okay, and then we'll come back and talk about what that vertex means. So I'm just going to graph it on Desmos and then find the vertex. So I'm graphing y equals 0.80 plus 0.05x times 15,000 minus 1,000x. So these are pretty big numbers, but my screen's already really big from the example that we did yesterday with the area. So this is already a pretty big window. So I'm going to try and get in closer and make this bigger, but there's my parabola, which the scale's huge. But I'm just going to tap where I think the vertex is, and it's negative 0.5, 12,000, 1250. So I get a vertex of negative 0.5, 12,000, and 12.5. Okay, what does this mean? Well, this, because it's revenue instead of a y value, so this here is the max revenue, which is $12,050. What it says, though, x is the number of times we're supposed to increase the price. But what they're saying, because it's a negative, they say don't increase the price, decrease the price. Well, if you decrease the price by half of our increment, which is 5 cents, because this is how many times we're supposed to decrease the price. Well, it's half a time. So really it's saying lower the price by 2.5 cents. So the question though was asking for the price. So we need to substitute this in here, and I would sell a ticket then for 0.80 plus 0.05 times negative 0.5, which is 77.5 cents. So basically 78 cents would be our ticket price.